A TV repairman finds that the time spent on his job has an exponential distribution with the mean 30 minutes. If we repair a set in the order in which they came in and if the arrival of the set is Poisson with the average rate of 10 per 8 per day, and what is the expected ideal time day, how many jobs ahead of an average set just brought in. So in this problem, the mean arrival rate we have to calculate it as 1 by 30 per minute, and 1 by 30 into 60 equal to 2 sets per hour. And finally, here we are going to find arrival rate. Arrival rate is nothing but an average rate of 10 per 8 hour a day, the customer will be arrival. So for 8 hours a day, 10 is your arrival rate. So you have to calculate 10 by 8. After calculating this 3, lambda and mu, you will go with the mean value. So rho equal to lambda by mu, and lambda by mu equal to 10 by 8 divided by 2. Reciprocally, you will get, cancelling the value, will get 5 by 4. The utilization of lambda by mu is 5 by 4 into 2, 5 by 8. You know that on an average of 8 per day, the repairman busy is nothing but 8 into 5 by 8, 5 hours a day. Ideal time of a repairman is 8 minus 5, so you will get 3 hours. So the total number of head is nothing but number of units in the system. So rho by 1 minus rho equal to 5 by 8 by 1 minus 5 by 8. So 5 by 8 by 3 by 8 equal to 5 by 3. So you will get, divided by 2, will get approximately 2 TV sets. Next we will go the next problem. A car arrival at a petrol bunk having a 1 petrol unit with an average of 10 cars per hour. The service time is distributed exponential with a mean of 30 minutes, 3 minutes. Find the average number of car and find the average number of time in the queue. Average queue length and the probability that the number of car in the system is 2. First of all, we have to calculate lambda per 10 per hour. Next, we have to go with the mu, that is 1 by 3 into 60. We'll get 20 per hour. Rho equal to lambda by mu, that is nothing but 10 by 20 equal to 1 by 2. Average number of cars in the system is nothing but rho by 1 minus rho. So 1 by 2 divided by 1 minus 2 equal to 1 car a day. Average waiting time is nothing but LQ by lambda, that is equal to 0.5 by 10 equal to 0.05 hour. So you will get 3 minutes per hour. Average queue length, we have to calculate it as LQ equal to rho square by 1 minus rho, that is 1 by 4 by 1 minus 1 by 2, 0.5. So probability of an n units in the system can be represented as Pn equal to Pn into 1 minus rho. So 1 by 2 whole square, 1 by 2 equal to 1 by 8. So like that we can calculate the system. So in this problem we have to calculate the average number of cars in the system, average waiting time in the queue, and average queue length, and finally probability that the number of cars in the system is 2. So these are the points we are going to cover in the all the 3 petrol bunks, and we have to apply the 3 formulas in that. One is rho by 1 minus rho, that is we are going to calculate the average number. Next, waiting time, we have to apply the LQ by lambda, and Q length we have to apply the rho square by 1 minus rho, and then our probability of the units Pn into 1 minus rate. So these are the calculation we are going to apply for the 3 all the 2 things. So this is of the model of an m/m1 infinity f/f/fc is nothing but an first come first serve. So there are the 2 models we are going to study in this queuing system, and in that queuing system first model will be very easy. So everyone can solve the problem. Okay, thank you.